I think, first of all, why is MEF working on IP services? IP services are very widely deployed. Everyone has them. They're out there in their millions. Why do we want to try and standardize IP services? And the motivation really comes down to automation. If you look at the situation at the moment, I'm a service provider. I need to partner with a bunch of other service providers to reach different locations. And at the moment, that's all bilateral agreements. So everyone has different terminology, everyone has different ways of doing things, everyone has different methods for how you order services from each other. And so trying to orchestrate or automate that is extremely challenging. Every other provider that you partner with has to be a whole project to integrate their things into your things and agree all of this stuff and agree even on the terminology and what you call things. So it's all very time-consuming and difficult. And the motivation for wanting to standardize IP services is to basically try and make that easier. If we have standard terminology, if we have standard service attributes, then that already makes the conversation easier, but we can also use those to create standard APIs and automate them, start to automate those inter-provider interactions. So here's an example, and this is a real example, by the way, contributed by one of our board members, of they have to talk to different partners. Some of them, when they want a new service from them, they have to phone them up and talk to them. Some of them, they have to send a fax, as if we're still in the 80s. Some of them have a web portal, but of course, they've all got their own web portals, and they're all different. Some of them do have automated APIs, but again, they're all proprietary, so they're all different for each other partner that they have to integrate. So the integration cost of trying to pull all this together and automate it is extremely high. So what are we trying to do? We're trying to automate the inter-provider service lifecycle. So that's right from initial, can you do this, quoting, ordering, inventory, billing, all of that stuff, right until it's torn down again. We started off by defining service attributes. That's always where we start. If you remember that figure from before over on the left. So we've done that. That's published. We're in the middle of doing service definitions. We have internet access coming out very shortly. We're working on private IP services now. And then the next step will be to start to define data models, information models, and APIs to cover all of that. And that work has also sort of already started. So here's a similar figure to the Ethernet one. It's a little bit simpler. We haven't done quite as much work on IP yet. But all of the service attributes are defined in MEF 61.1, and this is both for subscriber and operator services. It turns out for IP, they're very similar. So that's all in a single standard. It's quite a long standard. Service definitions, MEF 69 is another one that's being published, finally approved this Friday, fingers crossed. So that will come out very, very shortly in the next couple of weeks. There's more in progress there. That's just covering internet access to start with. We haven't got service definitions for operator services yet, but that will be what we work on next. And then some of the special topics, service OEM is actually done. We're just waiting for IETF to publish a draft so that we can reference it, which again, I'm told is imminent, but I've been being told it's imminent for quite a while, so we won't hold our breath on that. We've identified definitely a need to have a standard that talks about classes of service and bandwidth profiles for IP. And in particular for the interoperator case, having some standard definitions and around DSCP values and how those map to classes of service, I think would be very useful. And then service activation testing, this is again in progress. That's quite well progressed, actually. That should be finished in a few months. So again, if we dive in more detail, the service attributes, looking first at the subscriber case. So you'll see similar concepts here to the Ethernet case. We've just tweaked the names to make them suitable for IP. So we still have unis, user network interfaces at the boundary between the subscriber and the service provider. We now have IPVCs instead of EVCs. We've tried to keep the terminology consistent, even though IP doesn't really have connections in the same way, but we've used consistent terminology there, and endpoints. And then, some of the key attributes, although the constructs and the concepts are similar, the attributes are very different. So some of the key attributes for IP are things like the IP connection addressing at the uni. So, is it DHCP? Is it static? Is it SLAC for V6? The routing protocols across the uni, again, is it static routing, is it OSPF, is it BGP? Class of service maps, again, different because they're based on, mostly DHCP values, but we also allow class of service maps based on source and destination IP addresses and on the Ethernet PCP value and on TCP port number or UDP port numbers. So there's a lot of flexibility there in terms of how do you map packets into classes of service. Again, the service level specification. So this one is pretty similar to the Ethernet one, and all the stuff I said before applies to IP as well. There are objectives there for packet loss, packet delay, delay variation. It's essentially the same. We just replace the word frame with packet. And I have to always get that right depending on which standard I'm working on. And then bandwidth profiles. The bandwidth profiles are actually a little bit different from the Ethernet ones. The Ethernet bandwidth profiles have this very prescriptive algorithm that we use. For IP, we didn't think that was really the right approach because there's a vast amount of IP services already deployed and a lot of different ways of doing bandwidth profiles for IP. So we've tried to essentially define something that's consistent with what people are already doing and consistent with a lot of the work of the ITF. And I should mention actually that for IP services, we're not trying to define any new technology. We reference, I think, about 70 RFCs in this standard. We're not trying to redo work that's already been done in other bodies. We're just trying to pull it all together into one place and use it to define services. But bandwidth profiles and this is things like metering and policing and shaping and all of those sorts of things is an area where there's not a single clear way that it's done. There's lots of different options. So we've tried to create a bandwidth profile definition that can encompass all of that and hopefully sort of maps quite easily onto the different technologies. The operator case, it's again pretty similar. But now it's between operators. And again, we're building on the RFCs here, and the main one here is RFC 4364, which for those of you familiar with IP, you'll know is the standard that defines MPLS BGP VPNs. And it has these three options in it for how to provide IP VPNs across an ENI. They're helpfully called A, B, and C. If you're like me, you have to go and refresh your memory every so often about which ones A, B, and C are. But for the moment, we're only covering option A. The reason for that is that it's when we queried lots of service providers who were MEF members who were involved in this work, they almost unanimous response was, well, we only do option A. And we'd like to do option B, and maybe we'd like to do option C, but at the moment, we only do option A. So we've decided to just focus on option A first. We would like to come back and address option B and C later on if there's sufficient interest in doing that. And I think that's an area actually where MEF could provide a lot of value if we actually show how to do option B at a service definition level between providers. What things do you actually need to agree on to be able to enable that to happen operationally? The technological side of it is all specified there in the RFC. There's no issue there. But what's not specified anywhere is how do you operationalize that? If I want to do option B with another provider, what things do I need to agree? What do we need to agree on? What values do we need to agree on? How do we do that? So that I think is an area where MEF can help. So if you're interested in that work again, I said I would come back to this. Please come and join in. We can do that work as soon as we have enough people who are interested in it. And then the first service definition we've worked on is internet access. It might seem a strange one to do first, but it seemed like the simplest one. Well, at least when we started, we thought it would be the simplest one. Maybe it turned out not to be quite as straightforward as we thought. So we have this funny sort of diagram. And this comes back to that point about external behavior. Well, what does the service look like to the subscriber? And the trouble with an internet access service is that, with an internet access service, you connect to your service provider, your ISP, but then you can't see the boundary between them and the internet. The internet is just there. So we struggled a bit with how to draw that, and this is what we came up with. So you connect to the service provider, and then somehow it goes into the internet, and that's all a bit mysterious. From the subscriber's perspective, obviously, we all know how it works at a practical level. So we defined two types of internet access service. We called them basic and advanced, but essentially basic service maps to what would typically be bought by a residential subscriber or maybe an SME. So it's dynamic plug and play. It's DHCP. It's no particular routing. Probably no SLS or very basic SLS. But intentionally optimized for ease of use. The other one is advanced, so that's basically mapping to a more typical commercial offering. So you will have an SLS, be static routing, static addressing, and something more like a DIA service. I talked about that. So then finally, let's just look at what's going on in IP. I touched on some of this. Service attributes are for now done, but again, if there's interest in option B or C, we can work on that. On the service definition side, what we're working on at the moment is the private IPVPN service. That's fairly well progressed. It'll be coming out middle of next year, I would guess. And after that, we'll then move on to look at operator service definitions. On the special topics, so service OAM, as I said, we're just waiting for ITF to finalize one of their RFCs, and service activation testing is well progressed as well. Okay.